Hello everyone, we're going to start the rigid motions packet, and that's kind of a new term, although you know what they are, you just didn't call them that when you covered them in 8th grade. If you don't have the packet yet, most likely because you're 100% virtual or you're in a section that was here on a day that we didn't hand it out yet, you can pick it up from us if you're hybrid, obviously, when you get to school. If you're 100% virtual, between 2:30 and 7 p.m. on Wednesdays. That's going to be continuous now, every Wednesday in the library from 2:30 to 7. If that does not work, that's the priority. That's plan A. If there's some reason you can't get there 2:30 to 7 on Wednesday, they will do limited curbside pickup at the library. Who's not doing curbside pickup now, right? Even math packet people do it. So you just pull up to the high school and you call 518-459-1220, which is the high school phone number, and you ask to be transferred to the library, and you tell them that you're here to pick up some materials. You pull up to the library entrance and they'll bring it out for you. But plan A is 2:30 to 7 on Wednesdays. All right, so today, put the date at the top of this piece of paper if you have it. If not, we're using this as an Edpuzzle questions video anyway, so if you don't have the packet, you can go back and fill it in later. Blank paper is okay today. Rigid motions are transformations which preserve, that's a fancy word for keep, right? It means they don't change. Transformations which preserve distance and angle measure. So that just means they basically stay the same size and same shape. They just move somehow. And when you have a pre-image, that's before something happens to it, and after something happens to it, we call it the image. The types of transformations that you learned previously, probably in middle school, probably in 8th grade, you learned about reflections, you learned about rotations, you learned about translations, not to be confused with the overall topic, transformations, but translations. And then, draw a line here, you learned a fourth one, probably at the same time, called dilations. We're going to wait till probably, I'm guessing, January or February to talk about dilations. It's in its own category because it's not a rigid motion, because these three stay the same size and shape. This one changes size. So we talk about that differently in 10th grade. This idea of orientation ends up confusing people later, but really it's fairly simple. Orientation is just the arrangement of points around a figure. That's some of my best handwriting ever. I'm just going to stare at it for a minute. Maybe not to you, but I'm pretty messy. I'm happy with some of those letters, especially that F in figure. That's phenomenal. Okay, so clockwise and counterclockwise, if you think about it. When you go clockwise, if you ever looked at the clock in the classroom, clockwise goes the way the minute hand goes, 1, 2, 3, 4, 5, like this. So it's almost like if you had a steering wheel, it would be a right-hand turn on a steering wheel. Counterclockwise goes the other way, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It would be a left-hand turn. So if you looked at example 1 and it says determine the orientation of triangle ABC. Well, it's important the way it's written, A, B, C, in that order. If I go A to B to C, I went clockwise. So that one, we're actually going to write the word clockwise. And the next one, D, E, F. in that order. If I go D, E, F, I went counter what a clock does. Counter means against the clock, counterclockwise. So there are 4 transformations that you were introduced to in 8th grade. Reflections, translations, rotations, and even though we don't talk about it yet in this class, you were introduced to dilations. If I was to, I'm going to start with translation for a minute. If I go A, B, C, counterclockwise, if I translated something up here, right, translation is a slide, and I go A prime, B prime, C prime, I did the same thing. Nothing changed. They were both counterclockwise. So orientation was kept. It was preserved. So yes, it was. A rotation. A to B to C, counterclockwise. After it was rotated, I'm going to go A prime, B prime, C prime. I started in a different spot, but I still went counterclockwise. Counterclockwise, counterclockwise. It stayed the same. It was kept. It was preserved. Even a dilation, which we don't talk about yet, A to B to C, it's bigger now. A prime, B prime, C prime. Still counterclockwise both times. So yes, it preserved orientation. But this one, reflection, because it's a mirror image, and I went A, B, C counterclockwise, after you reflected it over this line, and I go A to B to C, it's now clockwise. So this one, orientation does not get preserved, does not get kept. Reflection is the only transformation where orientation is not preserved. We'll go quickly through this section here. The purpose of it is just to remind you that this whole idea of rigid motions, which are rotations, translations, or reflections, you can see examples of them there. A synonym for that, another word for rigid motion, is an isometric transformation, or sometimes called the noun isometry. They mean the same thing, isometry and rigid motion. Isometry is just Greek for same size. Those are the 2 Greek words I know. Non-isometric transformations would just be non-rigid motions. And that's where you have something like a dilation, where something gets bigger, size is not the same anymore. We don't talk about these two much, or this one much, but stretches, where it's like distorted. It might get bigger in one direction, but not the other. And in these cases, you would call those non-isometric or not rigid motions. Angle measure and distance or size are not the same. We're going to hold off on the bottom of page 4. At the top of page 5, just a recap, isometric transformation or a rigid motion preserves distance and angle measure. It keeps them the same. Are rotations isometric? Yes, they're rigid motions. They stay the same. Are translations the same? Yes. In fact, I can prove it with the iPad. If I was to just move this over like that, it stayed the same size. I just moved it. Obviously, the same thing would happen there. And we know reflections are. If you mirror image over that line, it's exactly the same. Non-isometric transformations are ones that is a transformation that does not preserve distance or angle measure. Are dilations rigid motions? No. No stretches, no. They change size. I think we've talked about what a stretch and a dilation is. And we'll talk more about that in the winter. Number 11. This pre-image of this dog, which you heard barking in the background just a little while ago, which are isometric. This one clearly isn't. It got too small. This one was stretched out and sort of painful to look at. This is actually isometric. All it did was get turned. You could cut this out with scissors and put it right on top of that, and it would fit. So what was this? This was a dilation. It got smaller. What was that? An ugly looking stretch. What was that? A rotation. I can't skip this one because it's a baseball. Which ones are isometric? This one was just rotated. This one looks like it was just reflected. And that one's not a rigid motion because it was stretched. We're going to skip over 7 and looking at page 8, let's see which of those 6 shapes on the right are isometric, which is a synonym of rigid motion, right? That's what isometric means. This one is, it was just rotated. That one got kicked in. That's not even the same shape. This one looks identical. It was just translated. This one got clearly bigger. This almost looks the same, but if you look closely, it's not the same size. It's not the same shape. And that definitely got smaller. So the only 2 that were actually rigid motions that you could cut out with scissors and put right on top of the other one, right on top of this one, would be A and C. And number 19 is an interesting question. Jane claims that any 2 circles are always isometric, which means they're always rigid motions, because the shape never changes. Interesting. Well, here's 2 circles, and you could say maybe the shape doesn't change because they're circles, but circles are kind of in a class of their own. These are not rigid motions because if I trace to this one and put it on this one, it doesn't fit, right? I would have to dilate it, and I wasn't allowed to do that yet. So no, Jane is wrong because circles can be different sizes. Something you'll learn in the winter is that all circles are similar, but all circles are not congruent. Obviously, there's bigger ones. So at the bottom of page 10, I'm going to jump down to that, which is example 21. I started here at pre-image, and I'm going to the image over here. You can see the only thing that happened here was it slid. And if you slide something without changing the size or angles, you are a rigid motion, you are an isometry. And when you slide something, it's called a translation. This example looks like I was turning it. I rotated it. That's also a rigid motion or an isometry. Rotations are rigid. You don't change size or shape. This one here, I can't really show it with this iPad, but if I got it right next to it, you might be able to tell that I could fold it right over that line, and that is a reflection. Because I didn't change size or shape, it is a rigid motion. Right away with this one, I'm going to circle no, because I can tell that this one is bigger than this one. It's either a dilation or a stretch, and honestly, we don't really need to talk about the difference in those 2 yet. That's down the road. This one, I can tell it's a stretch because if you look at it, it's still 3 boxes high on both sides, on both lefts, but clearly it changed on the bottom only. So it got distorted. So that's a stretch, which makes it not rigid at all. It was pulled apart. And this one looks like I could get it near each other and probably fold it up there and make a reflection out of it. I didn't change size or shape, so it is a reflection. We're going to stop there and pick it up with page 12 tomorrow.